Okay, good morning, guys. I hope you guys enjoyed your long, I'm gonna say long weekend, but it's not long weekend yet. We just had one a couple weeks ago. Okay, so let's get at it. Let's start with the land acknowledgement. We acknowledge we're hosted on the lands of the Mississauga of the Naushabee, the Haudenosaunee Confederacy, and the Wendat. We also recognize the enduring presence of all First Nations, Métis, and Inuit people. Okay, now we roll down and we see we're on day 10. Okay, day 10, we are into this new unit, Unit 4. We've went through Unit 1, Unit 2, Unit 3. You guys, I'm assuming everyone that's here on this call would have did Unit 3, which was due last Friday. I hope everyone did it. Right now, it's too late to ask me to open it up and submit it today. So I gave people lots of chances to submit it if they were going to submit it late. Okay. So we are now, you know what, before I even get into anything with the topic. So today, this is what we're talking about, trigonometry functions, yes. Understanding angles, identity, special triangles. We got a couple of worksheets, and then we have a quiz. And the quiz is due, by midnight today. But what's available now, if you go into your grades, I'm showing you here, in your grades, you should see your mark. The mark you see in your grades is the mark that's on the midterm that will be emailed tomorrow. Now, the midterm, it's a snapshot in time, right? So the midterm does not include, so hear me right now, does not include Unit 3. So it only includes Unit 1, Unit 2, and all the quizzes up to the quizzes inside Unit 3. So it doesn't include the Unit 3 test. That's what I should say. Okay. I don't know what's going on. You giving me, I emailed you. Okay. I'm not going to respond in this chat about that. Check your email. I sent emails. I sent you a video on how to submit in Google Docs, or make it a Google Docs, convert to PDF. I'm not sure what's going on. I sent you emails. So please, I mean, it's too late now. It's closed. You didn't check your email during the weekend, I guess. But moving on, we still have Unit 4 to do and Unit 5. And then there's a collimating, Part A, Part B. So again, your mark that's in grades only includes up to Unit 2 test. That means the test on Friday is not included. To Unit 2 test, and the quiz is up to the quiz that you did on Friday. Okay. Now, later on, after my lesson is done, you can click on this. This will take you to a quiz. This quiz, it's not a quiz. It's basically to confirm that you saw your mark. So I want you to go here after my lesson. Go here, and after you check your mark, click on that and say check your mark. That's it. They want to know if everyone checked their mark. That's all. That's the reason why we're doing that. Okay. Actually, I'm going to change the setting so I can look at it as a student. I want to see what you guys see. Okay. So look at it as a student. So if I click on this, will take me to where you guys can confirm your marks. Let's see what it looks like from your end. Oh, okay. Once you have reviewed your mark in the course, please complete this form and submit it to your teacher. Okay, this is basically just doing this quiz, I guess. That means you're just answering yes, you saw your mark. Okay, so let's go back to the main page. Okay, so what we're doing now is understanding the angles. So let's get into that. We're going to go to content. Okay, we're scrolling down. We're at, see, unit 5 is showing. It's there, but it's not activated yet. But because that means we're getting close to the end of unit 4. Okay, we have one more day for unit 4. Tomorrow it'll be the last day of unit 4, I believe. And on Wednesday, I'm giving you guys a heads up, on Wednesday, unit 4 test will happen. Today's Monday, so Wednesday unit 4 test will happen. So let's go to understanding angles. Okay, there's no video for this, so we're just gonna go, I'm just gonna explain it. Okay, we have to look at lesson for understanding angles, and then we have to look at trig identities. So two things. Okay, trig identities and understanding angles. Okay, so let's look at the understanding angles first. So when you look at, when you say understanding angles, you can see here by this screen here kind of shows you what we're looking at, right? We're looking at angles in the 4 quadrants, right? We have 4 quadrants in a grid, right? We have X, Y, and then X, Y creates 4 quadrants, right? Quadrant 1, quadrant 2, you can see quadrant 3 rotates, and then quadrant 4. Okay. Let's get into it. So here we're getting into definitions, coterminal and related angles. Okay, we're talking about understanding angles. So in this section, you learn how to identify different angles that have the same trigonomic ratio, as well as learn how they are related. To do this, you will have to visualize a terminal arm rotating around a circle centered at the origin of the grid with a radius of r. Okay, this is done so that you can extend our understanding of trig functions for a broader class of angles. Okay, so here is what we're talking about, our radius arm. We have a circle. This circle here, when you get into more into this, and you'll see this again in grade 12, this is a unit circle, okay? So unit circle just means that radius is 1. It's actually 1, but in a sense, it shows you it's 1 because that's the definition of a unit circle, okay? So here is the cast rule. You need to understand that. And we call this the cast rule because each of the quadrants from quadrant 1 to quadrant 4 labeled CAST. And what we're saying is the trig ratios that's created in each of these quadrants is positive. That's why, so if I create a trig ratio over here, down in this quadrant, whatever, if it's a cosine I'm looking at, it's going to be positive. If I create a trig ratio over here, and now when I say trig ratio, that means I'm creating a right angle triangle. That's what's happening, right? If I create a trig ratio here in quadrant 1, that means if I have a sine, a cosine, or a tan, they're all positive. If I create a trig ratio over here, that means the sine is only positive. Everything else is negative. Okay, if I create a trig ratio down here in the third quadrant, that means only the tan ratio is positive and everything else is negative. We have to get into examples because I know it's a little bit confusing right now. But now, this is what we mean by the trig ratio, okay? You can see here, this is my theta. And if I want to look at the sine theta, right? Sine theta is my opposite over my hypotenuse. Remember, r in this case will be the hypotenuse, right? And my y is the opposite. So sine theta equals to y over r, okay? And then if you're looking at for cos would be adjacent, which is my x, over hypotenuse. Therefore, adjacent is cosine theta equals to adjacent, which is my x, over my hypotenuse, which is my r. And tan theta is just equal to opposite over adjacent. So that means it's y over r. Okay. So that's your cast rule or your trig ratio. And then your bottom here is your cast rule. If I create this triangle over here, then if I'm looking for, like I said, for particular, say, sine trig, then only the sine trig would be positive. Okay, let's get into an example. Here we go. Here's an example. It'll make us understand this a little bit better. Okay, given that sine theta is 3 over 5, we're saying sine theta is 3 over 5. That means we're saying, right? We're saying, let me use a different color because we're using red. I'll use green. You know what? I'll use purple. Sorry. Okay. Since they say sine theta is 3 over 5, that means we know that here's your sine right here. Here's your theta. I don't like that color. It's still too close to red. I'll use light blue. Okay. So over here, from the theta, we're looking at our opposite and our hypotenuse. Our hypotenuse is 5 because we're saying sine theta is always opposite over hypotenuse. So our opposite is 3, our hypotenuse is 5. Okay. So if we have that, then it's saying here, determine the exact values for cosine and tan. Okay. Well, if I know, now the thing is though, right? We know this is a right angle triangle. If we know this here is 3, we know this is 5, we can figure out what x is because we're going to use Pythagoras theorem, which we did down here, right? So in order to figure out what x is, we're going to say x squared is going to equal to 5 squared minus 3 squared. And that's 16. And then x equals to 4. That's how we got 4 there, okay? So we know x is 4. Now we know all 3 sides of this triangle, this right angle triangle. Therefore, we can come up with the cos and the tan. Because cos is going to be adjacent over hypotenuse. Our adjacent is 4, which is x. Hypotenuse is still 5. And our tan theta is now equal to just opposite over adjacent, which is our y over x, which is 3 over 4. Okay? That's how you get that. Okay. So let's go on to the next example. So we have a bunch of examples, right? Now, like I was saying, our cos theta and our tan theta and our sin theta, they're all positive because they're in this quadrant, okay? They're in this quadrant, the first quadrant. They're in the quadrant of all, right? A is all. So all means they're all positive. Now we're going to look at other examples where the right angle triangle could be created in this quadrant or this quadrant or this quadrant, okay? Let me clear all the stuff that's on the screen. So here are another example, okay? Well, let's look at this question. Find both angles of theta for question 1 between 0 and 360 that have the same value, the same sine value. Okay, so find the angles. Okay, so here we don't know this angle, so you have to find this angle, right? But we know that in order to get the same, what do you call it? The same angle, the sides here are, or the ratios would have to be the same over here. Okay, so first of all, we have to figure out what this angle is over here, and we do. We figured it out. Let me zoom in a little bit more so we can actually see it. Too many things going on, so let's look at just this one here. Okay, so we're looking at, so over here we calculated sine through root of 5 is 37. So if it's 37 here, we can draw 37 over here and create this right angle triangle over here, right? So we're creating this right angle triangle with this being 37. But now we want to calculate, it says find where the sine value is the same, okay? Where the sine, so the sine value is only going to be the same, right? In this quadrant, because our sine value is what? It's positive. Since our sine value is positive, it's positive in the first quadrant, where all the trig ratios are positive, sine, tan, and cos. But in this quadrant here, you can see S, only the sine is positive. So when I draw my angle here, 37 degrees, it's going to be 37 degrees because the sine is 37 degrees. So therefore over here is 37 degrees, but we want to know what's this angle, and the angle we calculate is from 0 to 360. So we're coming from this side over to this side, right? We're going counterclockwise, and we're going to stop at this arm over here. And basically when we stop here, underneath the shortest distance has to be 37 because that has to match here. But up here, we need to know the angle from 0 to here. So that angle is going to be 180 minus 37. So that angle from here to here, okay, from here to here is 143 degrees, okay? And then I guess we're going to look at the cosine now, because the cosine, the only way you're going to find a cosine that's positive is in the cosine quadrant, which is down here. Okay, so I draw my 37 over here. Okay, so if I draw it over here, now I have to go from 0 all the way counterclockwise and get to 37 and stop by that arm right there. So then that would be 360 minus 37. So 360 minus 37 gives me 322 degrees. So cosine 37, okay, cosine 37 degrees is also equal to cosine 323 degrees, okay? Because over here, when I draw my right angle triangle, the only thing that can be positive here is my cosine in this right angle triangle. And similarly over here, when I draw my right angle triangle here, the only thing that can be positive is my sine, trig ratio. Okay, so let's go to another example. Find both angles between 0 and 360. So find both angles between 0 and 360. Okay, so first of all, what is this angle? We can use our inverse trig, right? So when we do an inverse of negative 0.7, we get negative 44. Okay, so what is negative 44? Because negative means we're going in opposite direction. Normally we go counterclockwise. So if we're going counterclockwise and we're saying negative 44, that means you're going clockwise. That means negative 44 is actually 44 over here. So now we draw our right angle triangle from here, and that angle is 44. The actual angle in the positive direction is 316. Okay. So the question is, find both angles of, okay, so of now our trig ratio is negative, right? So where is our trig ratio going to be negative? Our trig ratio is going to be negative because it's saying here, this is another point you have to look at. Our trig ratio is going to be negative for sine. It's going to be negative in the cos and in the tan quadrant. Okay, so we figured out the cos quadrant because we did the inverse of this trig. We got negative 44, which is over here. But then also too, we have to figure out what is the angle in this quadrant, right? So what would happen is I would draw another triangle over here. Here it would be 44 degrees, right? So we went from, then we'd have to go from here to here and figure out what that angle is. Well, that angle would be 180 plus 44. Okay, because we know that's 180 and we add 44. We know this one is 360, we minus 44. Okay, so whatever that amount, so we have our two angles are going to be 316, which we calculated here. And if I scroll down, I believe the answer is at the bottom here. There you go, 180 plus 44. Okay, so when you do that, then you get 224. Okay. Okay, so you got the two angles, right? 224 when it's over here, and then 316 when it's over here. Okay, so this is going to be similar, right? I don't want to take up too much time with this because we have to do another lesson, but this would be similar if it's saying find both angles between 0 and 360 where tan theta equals to 2.1. Well, the only place tan is going to be positive, since it's positive, is going to be in this quadrant here, first quadrant, and over here. So if that's the case, we calculate our angle is 65. That means from here to here is 65 degrees, right? And what we're saying is from here to here is also 65 degrees, okay? So if I go from here to here, that's one angle, and then I got to go from here to here, that's another angle. So if we calculate 65 degrees here, then over here it's going to be 180 plus 65. So we got here 245 and 65, okay? So that's getting pretty easy now, right? So I want you guys to look at that, and that's understanding angles. The next few are going to be, let's see. I'm going to let you guys look at these other ones. They're not that much difference from what we just talked about. We're going to go on to the next, which is identities. So let's look at that. Give me a second. I'm going to stop sharing for 1 second. Give me a sec so I can see the screen. Okay. Wow, it's giving me a hard time. There you go. Okay. So let me share the screen again. Okay, so understanding angles. Now there's questions related to that. Okay. You guys can work on those questions before you work on the quiz. Next one is going to be trig identities. Let's look at that. And then there's questions related to that. Okay, let me maximize the screen. Okay, so so trig identities. Identity is an equation that is always true regardless of the value of the variable. Okay, so regardless of the value of the variable, in this case, the variable in this case here, it is your angle. Okay, so your angle is the variable, but you can see it doesn't matter if that whatever angle is. If you have this, it's always going to be true. So here is inverse or reciprocal identity. So this is called cosecant. Inverse of cosecant. Inverse of sine is cosecant. Inverse of cosine is secant. And inverse of cotangent is tan. Okay, and then tan is equal to sine over cos. And then another identity over here is that it's called the Pythagoras identity. So sine squared plus cos squared equals to 1. So these identities, you don't have to memorize it, but just be aware this is what you're going to need in order to solve some other questions. Okay. There's some even tips here. You can see here, these aren't squared. Over here, they're not squared. And over here, this is not squared. But the squared version is still the same. So if I have cosecant squared equals the inverse of the sine squared, secant squared is equal to the inverse of the cosine squared, and then cotangent squared is equal to the inverse of the tan squared. And then you can have your sine squared over cos squared is equal to tan squared, okay? And then this is just isolating your sine squared and your cosine squared, okay? So when we're doing identities, it's all about proving, okay? So we have to prove the left side equals the right side. So that's what this is going to be about approving whatever statements in front of you, okay? So it says here, general tips to providing when you want to prove. So change everything to sine and cosine. We're going to go through this, right? I'm just going to just explain the steps here. If you have a fraction being added or subtracted, find the common denominator and combine the fractions. Use difference of squares when you have something like this. So difference of squares, you see you have 1 minus sine squared. That's, if that can also look like 1 minus sine, bracket 1 plus sine. That's a difference of squares, right? If you have, imagine this was, I don't know, x squared minus 4, okay? Then that would be x minus 2, then x plus 2. That's what we say difference of squares, okay? And then the power rule, right? So the power rule, if I have sine to the power of 6 theta, that's also equal to sine squared bracket to the power of 3, okay? So these rules can help you to solve the proving questions. So you have a question like this, you want to prove that, let me use a different color here. Maybe I'll just use black. Okay, so you want to prove cos theta times tan theta divided by sine theta is equal to 1. Well, what you do here is convert. Remember, it says to convert everything to sine or cosine. So this tan here, I'm going to convert that into sine and cosine. You can see here. That's what we did on this line here. As a result, the cosine cancels. And I'm left with what? Sine over sine. Well, sine over sine is just equal to 1. So right there, left side equals to the right side. Okay? You can see that. Okay, let's look at another example. Number 2. So we're going to prove this one, right? So we want to prove left side equals to this right side. So the left side is tan squared plus 1, and the right side is secant squared. Remember what we want to do is change everything to cos, and sine, right? So this tan, we're going to change that into cos and sine. So over here, right off the bat, tan squared is equal to sine squared over cosine squared plus 1. Okay. And now if I'm adding plus 1, remember it says get the common denominator. So common denominator for this would be cos squared. Okay, that's our common denominator. So therefore, this 1 is going to be cos squared times cos squared. So I'm going to have cos squared over cos squared. Okay, so now I can add them together because I need a common denominator. And then my denominator is going to be cos squared theta. But now I have sine squared theta plus cos squared theta. Remember, sine squared theta plus cos squared theta, that equals to 1, right? Based on the identities that we have up top. So that's how we got 1. So now we have 1 over cos squared. Okay, so now we're done. We can't do this anymore. Now on the other side, on the right side, we have secant squared. Remember, we want to convert that into sine. Well, inverse of secant squared is cos squared. There you go. So right side equals the left side. So now we proved it. Okay. Let's look at another one. Another example. Let's clear that. Okay, another example over here. Sometimes they get trickier, but we'll see. This one here is cos squared on the left side, and on the right side, it is 1 minus sine squared minus sine, and then 1 plus sine. Okay, now if we look at this one here, sometimes you can just, it doesn't matter if you start left side, right side, but if we look at this side over here, the right side, this is a difference of squares, isn't it? And if we write this as a difference of squares, then it's going to look like this, right? So we simplified it, right? Difference of square, that means we're saying 1 times 1, and then 1 times sine x, and then sine x, and then sine x squared, right? So now the middle is canceled out, and you're just left with 1 minus sine squared. Okay. Hope you guys remember difference of squares, right? That's what we've been doing in factoring, right? I hope you guys remember that. That's going to come into play a few times. So you have this, okay, is your final. And over here, you know the identity when it says cos squared x is also equal to 1 minus sine squared x, okay? You know that, and I'm going to say you know these identities based on from what we saw over here, okay? Right? It's right here. Okay, so that identity, Pythagoras identity, comes into play for this question here. Okay, that's example 4. Now let's look at example 3. Let's look at example 4. We're looking at this side over here, and then we're looking at right side over here. So if we're looking at the right side first, let's do the right side first. Remember, I want to remove a tan. I want to convert that into cos or sine. So I have sine times cos times tan. That tan theta can be converted into sine over cos. Therefore, the coses cancel. Okay. And I'm left with sine times sine. Then I got sine squared. Okay. Now this side here, 1 minus cos squared. Okay. You know from the identity, Pythagoras identity, 1 minus cos squared is equal to sine squared theta. Okay. So that's proved right there. Okay. Let's go on to the next example. Example 5. Now this one's a little tricky because you have this scenario here, right? And you have this scenario here. Okay, so let's just look at the right side first. Well, if I look inside the bracket, that identity, one, that's also difference of squares, but then you know the identity, 1 minus cos squared theta, right? Remember the identity way back here, right? 1 minus cos squared theta is equal to sine squared theta, right? Right? Sine squared theta. So we have sine squared theta in brackets, and we have to the power of 3. Okay, well now I know if I apply that exponent outside, multiply the exponent inside, I get sine to the power of 6 theta. Well, that equals to the left side. So that's proven right there. Okay. So we got that one done. Let's go to another example. Example 6. Oh, it's a little tricky now. Right? But the key is keep everything as look to see what we can transform. Okay. Well, I look at the top part. So this is your left side and then your right side. We're gonna look at the left side, but it looks like there's more stuff to do here. So if I look at the top part here, I can convert that into, using Pythagoras, I convert that into Pythagoras identity. That's equal to 1 minus cos squared theta. Okay, I have 1 minus cos squared theta, right? Now, when I look at that 1 minus cos squared theta, that's a difference of squares, right? So what does that mean? I can have 1 cos x and then bracket 1, so 1 minus cos x bracket 1 plus cos x, because that's difference of squares. And as a result, this is my denominator is 1 cos, 1 minus cos x. I can cancel. Now I'm just left with 1 plus cos x over here. And my other side, that's what I got. Okay, so now you got the final answer there. Okay. Let's look at another example. I think we are it for the examples, actually. That was the last example. So your questions, you're gonna have to basically prove or see if this is equal to that based on using your identities, okay? I believe someone keeps wanting to come back in. Let me close this. And yeah, so it looks like we are done with the identities. You can see here, these are all the identities. I kind of give it to you over here. And let's see here at the front. Special triangles. I believe we talked about triangles in understanding angles. Okay, so the quiz for what we've done here. First, don't jump on the quiz. Look at the worksheet. Let's see the worksheet. I want to see if what you guys see. I'm gonna click on that. I just want to see what you guys see. Making sure it's accurate to what you guys see. Okay. Again, this is not for marks. This is just to help you to be ready for the quiz. Okay. So these are typical questions. Okay. Figuring out the angles and what quadrant it is in. Okay. And these questions here. Again, not for marks, so it's only for you to practice. Identities here. Okay. Now give me a minute. I'm going to show you something else because I don't think I talked about it. It's not showing here. See, here's all the proving you have to do, right? So prove all this stuff, right? I'm going to talk about special triangles because I don't see it here and I want to pull it up. So give me a second. I'm going to stop sharing my screen and I'm going to pull up the special triangles and then have it in there. So give me a second, please. Give me a second. Just a moment, guys. Yeah, okay. I'm going to include this in some, yeah, okay. So, let's go through this. We have to go through special angles. So,
Here's the first lesson.
how long is this? We're going to have to go a little bit quicker on this. Okay. Okay, so here is a lesson on special triangles. I'm going to share my screen for that. Okay. Here we go.
For the trig geometry unit. In this lesson, you will learn.
You guys can hear it? Need to know in the chat. Okay. Thank you. So this is a little bit of a review of what we talked about, but we're gonna get into the actual triangle, okay? So it's saying a review trig, we already did that, so I'm gonna fast forward to some of this stuff. We already know about hypotenuse, we already know about opposite adjacent, we already know sine, cosine, and tan, we already know that stuff is gonna be SOHCAHTOA, we already know that, right? So let's fast forward that, we don't need to dwell on that, we already know that, okay? And we already know how to do calculations of that. So when we get to the point when we talk about special triangles. So we know our SOHCAHTOA. Yeah, some special triangles would be on there, but you already know about SOHCAHTOA, right? SOHCAHTOA, we did that already. So I want to get into the special triangles. We can fast forward that. Okay, so let's see where he talks about the special triangles. Okay, so there are two special triangles, okay? And that's what we want to look at here, right? So one triangle is isosceles, right? Where you have two angles the same, and they're 45. If the two angles are the same, remember this is a right angle triangle. So if you have two angles the same in a right angle triangle, they have to be 45, right? Because the one angle you know is 90. So if the one angle you know is 90, the two other angles, if the angles are the same, have to be 45, right? So this is one triangle here, right? Where the two angles are the same, okay? And then we have another triangle called equilateral, okay? Where you have the angles are 90, and then you got one angle is already 90, we already know that. But then we have 30 and 60, okay? So let's play it from here and we'll continue.
We can make up whatever side length we want for them, but the easiest thing to work with would be making them both length 1. And if they're both length 1, I could solve for the hypotenuse.
So what we're doing here is, what is the trig ratio for sine in this triangle? What's the trig ratio for cosine 45 or tan 45, right? It doesn't matter what number you use, right? If you know these two sides are the same, you can do 10 and 10, it doesn't matter, right? Then you use Pythagoras theorem to figure out what this is. But to make things easy, we use 1, because if I use this side is 1, that means this side is 1. That means this side here has to be 1 plus 1, 1 squared plus 1 squared is 2 squared. So this is going to be square root of 2, okay? So now if I want to figure out what is my sine 45, doesn't matter which way I go, sine 45, if I go this way, opposite over hypotenuse would be 1 over root 2. Cos 45, 1 over root 2, okay? And then tan 45 is what? Opposite over adjacent, which is just 1, okay? So that is, and because we're using, we're talking about 45 in this type of triangle, this always is the same. Later years, you know, this could be memorized. I remember when I was in school, we just had to memorize this because it would never change, right? And you would use this to help you solve other questions, okay? Okay, sorry about that noise, guys. I'm gonna mute for a sec. Okay, that was just a fire alarm, so just ignore that. Okay, so here is your special triangle, okay, for this one here. So let me clear that and fast forward. Okay, so we're gonna get to here. He writes it up. There you go. Then you're gonna have, again, opposite, adjacent, hypotenuse. There you go, right? And becomes 1. Okay, so now we're gonna look at the next triangle.
Triangle that has angles of 30, 60, and 90. Let's look at this triangle. Notice it used to be an equilateral triangle.
Okay, so this would be a big equilateral triangle, right? But then we divide it in half. So equilateral triangle, what is that? All the corners are what? 60 degrees, right? All the corners are 60 degrees. So this is a half of equilateral triangle, right? So when you're looking at this, right? Half of this, okay? So now, equilateral triangle. So what are the sides? Okay, are 60, 60, 60, okay? Now from here, you're gonna be using your cosine or your sine, depending on which angle you're looking at, which direction you're looking at, it's gonna give you your values of your trig ratios, okay? So let's watch.
If it was an equilateral triangle, all 3 angles inside that equilateral triangle would all be 60 degrees. And also, all 3 side lengths would have to be the same length. We could assign them whatever length we want. It'll be easiest if I say that they are all 2.
Okay, so now if we say all the sides are 2, because we're making things easy, right? So we're saying all the sides are 2. So therefore, when we say all the sides are 2, if this whole thing is supposed to be 2, we know this side is 2, and this side, but we're looking really and truly, we're only looking inside here, right? Inside there, because we're looking at half the triangle. So as a result, this here becomes 1. If we know this is 2, we have to figure out what this is, right? This is, when you do the calculation, right? This would be, I believe it would be root 3, right? It would be 1 squared So I'll do the math over here, right? So this would be the square root of 2 squared minus 1 squared, right? So 4 minus 1 is 3, right? So root 3, right? Because we're using Pythagoras rule to figure out what this length is. So if this is 1, this side is root 3, this side is 2, okay? So now if we're looking at, say, sine from here, sine 60 would be root 3 over 2. If we're looking at sine 30, looking at this way, right? Now this becomes opposite, and this becomes hypotenuse. So sine 30, if I was looking at, I'm going to change the color of my, making it red. I'm looking at this way. Sine 30 is going to be 1 over 2. Okay? And then cos 30, right? Cos 30 would be root 3 over 2. And then tan 30 would be 1 over root 3, right? It would be opposite over adjacent. 1 over root 3. Okay? And then if we're looking at it from the 60, I'm going to use a different color. Looking at it from here, looking at it from this direction, well, if I want to find sine 60, it would be opposite. Now this is root 3 over 2. Right? Sine 60 is root 3 over 2. Cos 60 is supposed to be 1 over 2. And tan 60 would be root 3 over 1. Well, root 3 over 1 is just root 3. You see how they're kind of opposite? Kind of? Okay. So that would be your special triangles from this point of view, right? So basically you have an equilateral triangle divided in 2, but all the sides are 2, 2, 2, 2, right? Right? You know, all the angles would have been equal, but we divided in half. So now I have 30 up here and I have 60 here. Always, that's always 90. So therefore, when you label it afterwards, you get this, okay? Let us, by the way, I'm going to put this in. This is a lesson that wasn't in there originally. So I'm going to put this lesson in, special triangle lesson in. It wasn't inside the content section. I'm going to put it in with, I'm going to put worksheet questions in there too. Okay. So worksheet questions, because you probably have maybe quiz questions related to special triangles. So let's fast forward a little bit. There you go. So then he's showing you what it is, root 3, over there, root 3. And then there you go. 1 over 2, root 3 over 2, right? Things I just showed you right there, okay? So let me clear my writing. Okay, so.
See how we can use that information. All sized right triangles with these angles.
So now, you know your special triangles. Here's an example of how you can use that information to solve a question, okay? So I know my right triangle. I know if this is 45, that must be 45, right? So the way it works, remember, this side is 1, if this is 1, this is root 2, right? So if I know this is 1 and 1, therefore if this is 4, this side must be 4, right? So then you have to do the math to figure out what that is, right? So let's clear that up. What's the question? Use special triangles to find the exact values of all sides and angles. Okay, so let's play it out.
Angles are similar, right? They would have the exact same shape. They wouldn't necessarily have the exact same lengths of sides, but their ratios of sides would be equal. Therefore, we can use these two special triangles to get exact values for trig ratios that involve 30, 45, or 60 degree reference angles, and we won't need a calculator. For example, it says in example 2, use special triangles to find the exact values of all missing sides and angles. Well, we're missing two sides here. I'll call them x and y. And we're missing an angle. Well, I know the angles in a triangle have to add to 180, so if this is 90 and 45, it'd be easy to find the other one is 45 as well. Now we could solve for the missing sides without using special triangles or SOHCAHTOA, right? This is clearly an isosceles triangle, so those two sides are the same, and then we could use Pythagorean theorem for that. But I want to make you comfortable with how we can use exact trig ratios to solve for things, so we'll do it a different way. Let's make the 45-degree angle the reference angle. That would make x the opposite side.
Okay, so if that's the case, right? So this is what we're doing here. We're going to use we're using the special triangles in order to figure that out, right? So the special triangle, right? We write this out, say this is tan 45 equals to x over 4, because the only thing we know is 4. So we don't know the hypotenuse. We want to know what x is, so we're going to have to use the 4, right? So x over 4 makes it a tan, so tan 45 equals to x over 4. But we also know the trig ratio for 45, right? We know the trig ratio, right? So what the trig ratio is, I'm going to write it on the actual triangle here. I'm going to use a different color. Use red. We know the trig ratio, right? So if this is 1, if that's 1, this is root 2, right? And we know that we're back up top there, tan 45. I'm trying to use my mouse to write the angles. So sorry if I go slow. Tan 45 is equal to opposite over adjacent is equal to 1, right? So if these two are the same, because we're saying tan 45 is equal to x over 4, so I can set these two things to the same, right? Can't I do that? Right? That means we can say x equals to 1, or x over 4 equals to 1, right? And if that's the case, get x by itself. Okay, that's an x. Oh my God, that's an x. So therefore, x equals to 4. But we already knew it equal to 4 because all the sides are the same. These two sides must be the same. But this proves it right here. This shows you how it's equal to 4, right? Because I know my trig ratio, tan 45 is equal to 1. So therefore, x over 4 equals to 1. Then I solve for x. Okay, see how you use that? Now that could be used for, say, the other special triangle when we're dealing with 60, 30, 60, 90. Okay, so let me clear that. And let me fast forward. He's going to show the exact same thing I just showed you. There you go. Okay, so he just showed you that. So now, and then for cos 45 would be the same thing, right? Cos, if you want to know what the y is, right, we have to get into the hypotenuse. So we have to use 4 over hypotenuse, adjacent over hypotenuse. Therefore, we have to use cos. So what's cos 45? Cos 45 would be 1 over root 2, right? Based on the special triangle. So 1 over root 2 would equal to 4 over y, right? Back up.
I can replace cosine 45 with 1 over root 2. To isolate y, I can...
There you go, right? So now isolate y, and then you get your answer for y.
can do some cross multiplication and get y equals 4 root 2. Let's try this again.
Okay, so now here's another one where we're using the 60. So 60, 30, 90. Okay, so let us continue with this one. Remember that this here would be 30. It would be 30. Okay, therefore this would be 1, right? And this side would be 2. Okay, and then this side would be root 3. Okay, that's using a special triangle. But now we give you the side here. We give you the side, so we have to figure out what would the other sides be. Remember, we know the special triangle, so that means if I'm looking at it from, say, 60, right? I can say, let's look at, say, I guess we're going to use sine. Let's use sine. Right? Let's use sine. So if I use sine, so sine 60 in the special triangle, sine 60 in the special triangle would be root 3 over 2, right? In the special triangle. But we're gonna have that, and we're gonna say we want to solve for this side over here. I don't know, let's call this one R. You know what, I'll call it H. Okay, so if I want to solve for H, sine 60 is also equal to this number here, 3 root 3 over H, which is the hypotenuse, right? We don't know what a hypotenuse is. I think he might use a different letter. He might use X, Y, I don't know. Right? So if I want to find H, well, I know what this is. So I just set these two together, right? So this will be root 3 over 2 equals to 3 root 3 based on what we have, the numbers we actually have here, over H. Okay? And now we solve for H. This could be X, Y, I don't know, whatever letter they use, but now solve for H. Cross multiply and isolate H. Okay? So I'm going to stop soon here. Let me clear my screen. Let's fast forward. Right? There you go. He uses X instead. We know that was H. Okay. And what does he do? Yep, that's what he did. Right? Because like I said, sine 60 is equal to root 3 over H, but he calls it X. And then sine 60 is also equal to, using a special triangle, it's equal to, it'll show you on the screen, right? It's equal to root 3 over 2. Now X equals to 6, okay? So now with these examples here, determine the exact, you can plug in the special triangle angles in here, or not triangles, special triangle ratios in here, and then get your final answer, okay? So we'll do this example one last time and that's it, right? I'm plugging in my special triangle values, okay? That's what I get, right? If I get that, that becomes 1 over 2. This becomes 1 over root 3 over 4. Get common denominator, that's what you get, right? This one here, you know, that's sine times sine. That's going to be whatever the special triangle is there. It's a half, I guess, and a half squared. So, and that's what you get, okay? So one thing you should remember is how to rationalize denominator. Denominator, when it says rationalize denominator, that means fractions should be simplified so that the denominator contains only rational numbers. That means there's no radical in the denominator. If I have a radical in the denominator, I have to change it by rationalizing the denominator. This shows you how to do that. It's a very quick thing. You just multiply top and bottom by the radical, and then you get rid of the radical in the denominator. Okay, and that's what that means. Okay, now same thing here. How do I get rid of that one? Well, I'm going to multiply top and bottom by, it's almost like you're going to do difference of squares. So 1, so my bottom will multiply 1 minus root 5, and then multiply the top by 1 minus root 5. Okay, there you go. And now it's like here, like doing difference of squares. Okay, so now what happens is the bottom, the radicals cancel out because I'm going to do like a difference of squares multiplication there. And I just left with the radical in the numerator. Okay. And that's what I have in the bottom.